Alright, so we've got some more things to talk about with circles. Okay, so today we're talking about segments in circles. Okay, when we think about segments in circles, we're going to have circles where we have intersections on the inside and intersections on the outside. Okay, now what this is going to look like for us, okay, is if they intersect on the inside, okay, then two lines come and meet together on the inside. Okay, if our intersection is on the outside, okay, then those lines are going to come together and meet somewhere outside of our circle, like that. Okay, and then we're going to, later on, you do have lines that intersect, segments that intersect on the circle, okay, but that's a special case. Okay, so we might have where one goes through the circle and one is outside of the circle that looks similar to this. Okay, my line's got a little off here. Alright, and that's going to be a special case that we'll talk a little bit about later on. Okay, so as we get into this, we've got quite a bit of highlighting that I'm going to do to make sure that we are all on the same page. Okay, so this first one, again, we're talking about segments. We're looking at length. Okay, this first one we have line PQ and line RS. Now you can see that the intersection of these lines are on the inside of our circle. Now when our lines go through a circle, okay, and they intersect the circle at 2 points, remember we call that a secant line. So this equation has two secant lines, so we would say secant, secant. Okay, and they intersect on the inside, which is important. Okay, so they intersect inside the circle. So our equation here, we have something times something equals something times something on this other side. Okay, so what we're looking at here is we're going to have the green part times the green part. Okay, those first two have to come from the same line here. Okay, so the part that we're talking about goes from the point on the circle to the intersection, so PE times the other part of that line, which would be EQ. Okay, so we would have PE times EQ, okay, equals our other part, okay, which is part times part, which comes from our other line, which would be this part, RE, times this part, ES, which I'm going to put in the pink highlighting. Okay, so RE times ES. So again, your generalized form that I like to think about is that it's going to be part times part on your green line equals part times part on your pink line. Okay, so if we look at the examples that go with this, okay, there's one on the foldable if you're filling in the foldable, and the other one comes from the extra examples part. Okay, whatever pieces you have, you just go from there. Okay, so one of your segments on this first example is we have from A to C. Okay, so our first part here is from A to B, which is the 6. Our second part is from B to C, which is our X. So we're going to have 6 times X equals. Okay, then we have to look at your other line, which is from D to E. And we have one of our pieces from D to B is 3, and then from B to E is 8. Okay, so that's on our other side, and we're going to have 3 times 8, and then you are just multiplying. Okay, so 6 times X is 6X, 3 times 8 is 24, divide by 6, and we end up with X equals 4. Okay, now one thing I do want to talk about with this example is sometimes you have it where it's like, instead of just 8, it's like 8 plus X. Okay, if it would have been 8 plus X, then we would have just said 3 times 8 plus X, and that 3 would have had to get distributed, and you would have gotten 24 plus 3X. Okay, so if the problem looks like that, then just make sure that you're distributing that to both things in the parentheses. Okay, your second example just asks you to go one more step. Okay, and it says find the measure of the radius of the circle. Okay, we're still intersecting on the inside of the circle here. Okay, our intersection of these two segments is actually right there, and I'm going to call that point F, just so that we can talk about this a little more clearly. Okay, and so we're looking at our first secant, okay, which would go from A to B, and the numbers that go with that are 24 and 24. Okay, so our first part of our equation would be 24 times 24 equals. Then we have to look at our other secant line, okay, and that would be from C to D, which is actually our diameter, right? It goes through the center. Okay, and our pieces that go there are 12, and we don't know what CF is. From C to F right here, so we're going to call that X. So our other side of our equation would be 12 times X. Now, to find the radius, we first have to find the diameter, which means we have to find that missing piece, that X, first. Okay, so we're going to say 24 times 24 gives you 576. 12 times X is 12X. We're going to divide by 12. Okay, and we're going to end up with X equals 48. But that's not my final answer. That's just what this piece is. Okay, so if X equals 48, okay, then the diameter would be 48 plus that other piece, which was 12, which gives us 60. So then to find the radius, we would say 60 divided by 2, which gives you 30 feet would be your radius. Okay, so that's the first equation that we're looking at. Okay, our second one you see on your foldable says no segment property. This is when we intersect on the circle, okay, and we have no relationship when they intersect on the circle of the segment, so there are no examples for us here, so we're going to keep on moving. Okay, your third one looks like this, where we've got two secant lines, okay, but these secant lines intersect on the outside of the circle. Okay, so that's going to be important. Now, when it says our rule is secant times the outside equals secant times the outside, okay, I don't love using that secant word. Okay, I actually want you to think whole. Okay, so whole times the outside equals the whole times the outside. Okay, so what does that mean? What am I talking about when I say whole? Okay, what I'm talking about is the whole secant, okay, would be from the intersection point to the point that's on the circle right there. So your other secant would be on this other side, and it would be from that outside point to the point that's on the circle, so from P to E. Now the exterior part that we're looking at, this outside part, is the part that's just outside of the circle. So the length from P to A and the length from P to D is what we're going to be talking about. Okay, so your equation is actually with the letters. Okay, your first secant, your whole secant, is PB times the outside of that segment, which is PA, equals the whole secant on the other side, PE, times the outside, which is PD. Okay, and again, this intersects on the outside of the circle. Okay, so let's look at our two examples here. Okay, we have to be careful here because that whole piece, you have to find the length of that whole segment. Okay, so our whole segment here on this first example is from T to R. So to find that whole segment, okay, we need to add together 16 plus 26, which gives us 42. So likewise, we're going to have to add together on the other side, which is our 18 and our x, to where we get 18 plus x. Okay, now you have to be careful because 18 plus x and 18x are not the same thing, so this would be wrong. Okay, so those are our wholes. Okay, so this would be our whole from t to s, so we're using the 42 as a whole and the 18 plus x as a whole. And then your outside pieces are going to be your 16 and your 18 here. Okay, so let's set up this equation. We would say the whole 42 times the outside 16 equals the whole 18 plus x times the outside 18. Okay? Now, we're going to multiply 42 times 16, which gives us 672 equals. On the right-hand side, we've got this 18 plus x and this 18, which means we have to distribute to both things in the parentheses. So we get 324 plus 18x, and then you can just solve. So we're going to subtract 324. And we get 18x equals 348. Divide by 18. And we end up with x equals 19.3. And it just asks us to find x, so that's it. Okay, so let's do one more example. Again, we have two secants. They intersect on the outside at point V. So we need to find the whole length from V to A. And we've got V to R is 6 and R to A is 4x. So we've got 6 plus 4x. Okay, then we've got the other whole side from V to B, which is 6 plus x plus 3. Okay, which ends up giving us x plus 9. So make sure that you're being careful there. Okay, that we get that correct whole thing. So here's one of our wholes. Here's our other whole. And then our outside pieces would be V to R, that's 6, and V to H, that's 6. So let's set up our equation. Okay, our whole 6 plus 4x times the outside 6 equals the whole x plus 9 times the outside 6. And here we've got more distributing, all right? We've got to distribute here, and we're going to distribute on this side. Okay, we get 36 plus 24x equals 6x plus 54. Okay, now make sure you're being careful when you've got these, and we've got x's on both sides. Okay, we're going to subtract 6x. Get 36 plus 18x equals 54. Subtract 36. We're going to get 18x equals 18. Divide by 18, and we end up with x equals 1. Okay? So those are maybe a little more tricky. Just make sure you're being careful about what we are solving for and making sure that we are adding those together. All right, so our next one is similar, just a little bit different. Okay, this one we have a tangent line and a secant line. Okay, so just like we did on that last one, when we have this secant right here, we want to make sure that we're thinking about that whole secant times the outside. Okay, and that tangent is our tangent squared in our formula in a second. Okay, so our tangent, okay, would be where we hit our circle one time, like we talked about in the last video. Okay, so QG would be our tangent, equals the whole, right, our whole secant, okay, which would be from Q to J, times the outside. Okay, and our outside would be from Q to H, right there. Okay, so we would say in our equation that QG squared equals QJ times the outside, which is QH. Now, this one also intersects outside the circle. just as a point of reference for later on. Okay? So looking at our first example here, we see we've got a tangent, and our tangent where we hit one time is yp. And then we've got our secant that goes all the way through the circle, and so this whole thing would be x plus 2.2. Okay, so our blue piece, our tangent piece, is 3.3. Our whole secant is right here, this whole thing, that x plus 2.2. And our outside piece is just 2.2. So we say tangent squared, so 3.3 squared equals the whole thing, x plus 2.2, times the outside 2.2. We're going to distribute on this side. When we multiply 3.3 squared, we get 10.89 equals 2.2x plus 2.2 times 2.2 is 4.84. We're going to subtract 4.84 on both sides to get 6.05 equals 2.2x. Divide by 2.2, and you end up with x equals 2.75. Okay. Now, they asked for mt, which was just x in this case. But if they would have asked for pt, then you would have just put it in 2.75 plus 2.2. So make sure that you are giving what they asked for. Okay, similar idea on this second one. Alright, just one more example for you. We want to find GW. Okay, so we have to be a tad more careful on this one. Okay, our tangent piece would be GH, that 13. We need the whole GW by adding 9 plus 5x. Okay? And then our outside piece would be that 9. And into our equation we go. So we say 13 squared equals the whole 9 plus 5x times the outside 9. 13 squared is 169. Here we need to distribute, so 9 times 9 is 81. 9 times 5x is 45x. We're going to subtract 81 on both sides. Okay, and we get 88 equals 45x, and when you divide by 45, you would get x equals 1.99, repeating, and a 5 on the end. Okay? Now, I think on our paper we said that it was approximately 2. Okay, so when we plug this back in to find GW, we would just say GW equals 9 plus 5 times 2, so we would say it's about 19. Okay? Now, the last part on your notes is that tangent segment equals tangent segment, and we talked about that in the last video. Okay, so here we would know that RM is tangent and RN is tangent, so we would just say RM equals RN. Okay, and you know that those lengths will be equal. Okay, so you just want to look back at that page in your notes. Alright, so I hope that you are feeling confident about segments. Make sure that you use the notes when you're working on the assignment. Alright, good luck with segments formed by secants and tangents.